The first topic I will show is the motion control of photoresponsive liquid crystal droplet. So the first demonstration is about MBBL, which has the photo response, and also the MBBL itself makes a liquid crystal. Then the droplet itself, made of the liquid crystal and photoresponsive molecules. Okay. So first, we prepare the droplet by using the microfluidic device. In the microfluidic device, the inner and outer fluids were introduced into the thin capillary. And what happened inside here is the inner fluid and outer fluid counter-propagating to hit here. And then due to the shear force applied to the inner fluid, the droplets were generated and collected inside the capillary. And you could see this image. So here are the sample information. As I mentioned, inner fluid is MBBA. The molecular structure of MBBA is like this. So it has a CN double bond, which is photoisomerized by UV light. And as an outer fluid, we use the SDS solution. And here the observation setup. Basic setup is inverted microscope, and we prepare the glass cell. The cupboard was sandwiched with a rubber spacer, and then you could observe the motion of the droplet, and UV LED was illuminated from the top side of the microscope with some oblique angle. So here's a first demonstration after investigating many different experimental parameters. Finally, we could find a motion. So by illumination of UV light, it start rotating, and when the UV off stopped, and then started again. So it seems like under some experimental conditions, we could successfully move the liquid crystalline droplet by light. And the next one, we studied it's really depended on the UV light. So we studied the light irradiation direction dependence. So when the light was illuminated from the right side, first, once the light is on, it starts rolling. And then when it's off, it's going around a bit. And then when the light is on again, moving toward the right side in this image. And when the light was illuminated from the top side, when the light is on, start moving upward like this. So obviously, motion direction depending on the light irradiation direction. And also, we study the light intensity dependence, and clearly it shows some sort of the linear dependence of the velocity on the light intensity, and clearly indicate that this motion was induced by the light. And also study the surfactant concentration dependence. And there was some threshold concentration we could find. And here's a concentration and the velocity. And if you expand here, you could see at some concentration, the motion was jumped up, started. And actually, the necessary condition was a little bit higher than the CMC concentration. So the necessary condition is the concentration of the surfactant solution must be larger than the CMC concentration. So based on these results, we could observe on-off population and irradiation direction dependence, light intensity dependence, and concentration dependence. This motion of photoresponsive LC droplet could be induced and also controlled by UV light. So why did this happen? So I would like to remind you that in the field of active matter, this motion was induced by the Marangoni flow induced due to the surface tension gradient. So, and which was induced by the solubilization. So first, we tried to investigate the solubilization happened actually or not. So what we did is we put MBBA droplet inside the solution and we illuminate the UV light, and every 5 seconds we picked up the outer solution to the qubit and measure the absorption spectrum. And what we found is as time passed, the absorption spectrum in the outer solution gradually increased, and this absorption profile corresponded to the MBBA solution. So obviously, MBBA was solubilized into the outer fluid. And then the other experiment we did is we tried to illuminate the UV light from the top side, so vertically down to the droplet. In this case, when even the UV light was illuminated, no motion was induced. So it means some sort of the angle is necessary for inducing the motion. So possibly some sort of the inhomogeneous surface tension must be induced. And the other things we confirmed is the convective flow. So because it is expected that there should be some convective flow inside the droplet. So we observed it from the bottom side of the droplet. So when the UV light was illuminated, you could see clearly that some sort of the motion flow was induced inside. And I would like to remind you, it's observed from the bottom side. It means the convective flow is like this direction towards the UV light, and then move toward the light source. So finally, we consider the mechanism of this motion. So here's a side view and the top view. And we need some sort of the oblique angle irradiation. And then one side of the surfactant and liquid crystal was dissolved and solubilized. And then there should be some surface tension gradient, and which caused the rotational motion, rotational flow, and there should be some sort of frictional force on the surface that makes this object rotating on the substrate towards the light source. So here's a summary one. We could demonstrate photo-induced motion. This motion was generated by the light-induced molecular flow inside the droplet.